Yeah, I think we could start. Then, the others could join. Hello, everyone. So this is the lab for chapter 2. It's quite long because it's meant to be like a comprehensive review of like almost all the Python we need. Let me not say all the Python, but at least to put us to speed with Python, so that in the subsequent labs it will be easy to follow along, and we will not have to struggle a lot with the Python codes and syntax. So that's basically the main focus of this lab. So he talks about getting started. So he's assuming that, let's say we have zero Python, maybe someone coming from R or something like this, and you have zero Python. So he's assuming that first you have to install Python 3, and then you get access to Jupyter Notebook to get started. So one could get that from Anaconda. I guess we all have that, yeah. Or you could use the Google Colab, which is available online, so you don't need to install anything. But if you want to use, you could also use the Jupyter Hub, or you could use the installed version through Anaconda, which is what I'm using. So once you have that, we could also get access to the materials from the website. We could download the materials, including the data sets and also the labs and all the labs. Yeah, and then once we download everything, we will also have to install the islp package, which will provide access to all the data sets. We could just do that by just using the pip install islp, and then that's done. So to run the lab, we just download the file, which is from the website. Once we're at the website, you could just, let's see. Yeah, so from here, once you go to resources, you could, it's, okay. Anyways, it's not going. Yeah, so from there, from resources, we could download this folder, and then we could run it just like I did. So once we run it, we could get the chapter we're interested in. Yeah, so to run the install version, you must have installed Anaconda, and then it will work. Yeah, so if someone wants to add anything on this before we start the codes and all that, feel free.
No, no.
Okay.
I've never used Google. I didn't use the Google Colab. I had a standalone installation, but everything was fine.
Yeah, I once tried the Google Callouts, but I think that was maybe a year or so. I just followed a guide on how to use it, but I'd never use it seriously. So well, we start looking at the basic commands. So he starts with telling us what a function is, or if you want to call a function. Suppose we have a function called fun. So if you want to call the function, we have the inputs of the function, or the arguments. So we can think of a function like a black box, wherein we give it some inputs and it gives us some outputs. So we don't necessarily have to know what is inside the black box, what it does, but we have to know what it accepts as an input and the type of output it gives us. So if we know that, then we could call any function, which makes life very easy. Imagine if there were no functions, then it means every work you do, you have to create everything from scratch, which is very difficult. So example, one of the most used functions is the print function. So you just give it the inputs, which is fit a model with 11 variables, and then it gives you that. or the first thing you will write, print hello world, and then it gives you that. But let's say most of us don't go to the details to know what the print function does in the background. So just like in R, so if you want to know what a particular function does, we could just type the function and a question mark, and then we'll see the main sort of building blocks of the function. Or we could, I think, help also with the function should work. So this way we'll see what the function does and what are the main arguments it takes and the type of output we expect to get from it. Yeah, so then he starts doing some basic arithmetics like in R or in any other programming language. You just add, yeah. Okay. Yeah, so when we add 2 plus 3, we have 3 plus 5, we have 8. So we could use this as a list. Later he will discuss lists or the data types. So he will discuss the different data types we have. So the first, these are strings. So string, hello world, like string is basically how Python represents a character or let's say letters or stuff like that. So what makes us know that is a string, it's because of the apostrophes we have. So either we have a double apostrophe or a single apostrophe, it's still it's still a string. But what is important is to be consistent in what we use. So so this concatenates the string. So we can add two strings together. Like here, this just creates the space here, and when we concatenate the two strings, when we print out, we have hello world. But then this will not work because here this is a list sort of. X is this, and Y is this. So if you add the two, it doesn't add column wise. It concatenates. It doesn't add column wise because this is not. It's not a. It's not treating it as a. It's treating it some kind of like a. It's not treating it at like an array or something like that. So this is why he will introduce numeric programming of NumPy, which will represent which will transform X to some kind of array, like a vector or a scalar, and then we could easily add them together. So now he introduces the main packages we use in Python to do data analysis and some other statistical related works, which is the NumPy and pandas. So numerical Python, which is in short NumPy, is a library or a package. So it's a collection of models that are not necessarily included in the base Python, just like we have in base R. You know, if you want to use ggplot, you have to install the package because it's not a base R package or function. So the same thing applies to NumPy. It's not a base Python, so we have to install the package. So like we can install it like this. We could import NumPy as NP, and then we are good to go. So now we just call it as NP. So in the previous examples, now X is a NumPy array and Y is also a NumPy array. So we could concatenate. We could add them. We could do some mathematical operations with them, since now we had convert them to an array. So which is seen as some kind of a vector or something like that. So we could add them. When we add X and Y, we have it adds the corresponding element in each of the in X and Y. So in NumPy, so the matrices are usually two-dimension arrays. Of course, we can work with more than 2 dimension, but generally the matrices are in 2 dimension. So we could create a matrix by calling the np.matrix, but we can also use the np array and it just takes it as a matrix. So we could also ask the dimension, that is the dimension of the matrix, which he mentioned. Normally we work with 2 dimension. We could work with 3 dimensions, but that's not very common. So the D type, which is the data type, we want to know the type of data, whether we are working with an integer or we are working with a float, or let's say a Boolean, which is like a true or false. So that is usually very useful, and we want to know the type of data we are working with. So we could just call the method the D type method, like the data type of, let's say, the particular object we are working with, let's say the data frame or something like that. Oh, but we could also, if we have an NumPy object, we could assign it to a particular data type. We could assign it to a particular data type, or we could just call the dot data type to give us the data type. Here, this NumPy array is a float 64 because of this dot because of this 3.0. That's why it's a float. So if we have only one, even just one of the elements a float, then the object becomes a float data type. So if you want to know more about this function, we could just call the help. We could just type and say, what does this mean? And then it will tell us what it means. Or it will give us the documentation, sorry. Yeah, that's it about. So we can also use the reshape, the shape, which gives us the number of rows and columns we have. Yeah. So these are 2 by 2, like a two rows and 2 columns matrix. So it's a squared matrix. So we could also change the shape. We could also use reshape. Yeah, we could also use reshape. So I'm not sure of that. Metrics, I'm not sure whether we could have n dimensions. If maybe, I don't know if someone knows something about that.
Yeah, I think we can create high dimensional matrices like 4 times 4. Yeah, I think I tried this before, and it's not only limited to the convenient 1 or 2 dimensions.
So if I understand what we're talking about, dimensions is like the axis, like the X and Y axis.
Yeah, the shape. I mean, I think it's yeah. I mean the shape of the array.
Yeah. Okay. So the shape we can have up to n, like, but the dimension, can we have a matrix that is more than 2 dimension, that is more than XY, let's say XYZ matrix?
Yes, there's no limit. So this is often NumPy or abstractions are used for like TensorFlow or PyTorch. And I don't believe that there are, it's going to be dictated by your system memory. But I don't believe, as Hamza mentioned, I don't believe that there's any limits on the maximum number of dimensions for a NumPy array.
Yeah. I think I want to. I think that's it, because I some time ago I read this book on by Wes, Python for data analysis. I think he mentioned something like that. So we can go beyond 2-dimension, but I think it gets more complex beyond 2-dimension.
Yeah, and the output of the shape function will be a tuple with more than 2 items. So here you have two maybe. Yeah,
Like here.
2 separated by 2. But in case you have a 3-dimensional matrix, you would have, for example, a tuple, an output with a tuple consisting of 2 and 2 and 2, for example.
Oh, okay.
And by the way, you can try that in the upper cell by, for example, adding a third list, like
Yeah. Then
beside the.
I'll have to import this stuff.
Yeah.
Yeah, I have to. Okay, let's see. So you're saying I try to add one here?
Yeah, another 1 or 2 or more than one list.
Let's see. This. Let's see how this looks. Like something like this, right?
Yeah, exactly.
Yes.
And now you can check the number of dimensions in the cell right down below. Yeah.
Yeah. So it's still 2D.
Us.
Yeah.
Let me check. Yeah, we sorry, let me type the metrics in the messages so you
Yeah,
can.
you type in chat, then I can see what
Yeah.
you're saying. Yeah. Or we could just add Z here and see how it looks.
Yeah, I just sent it out. You can
Okay.
check it.
We try together and see how it looks. Let's see the
You have to add n before dime, n dime.
so like the NP.
N and then dime. Yeah, you're good.
Okay. So that's a 3D.
And you can check the shape. You will have the shape of each dimension, the number of items in each one. Yeah, it's okay. You're good.
Okay.
Yeah.
Yeah. Okay.
I would say it's kind of confusing, but I guess by practicing it would be
Yeah. By
easier.
practicing it be. Oh, thanks for this. Yeah. Thanks.
Yes, a lot of bracket
Yeah.
inside.
So you can easily mix up one of the brackets and then the whole thing's collapse.
Yeah, exactly.
Yeah. This is good. Yeah, I think it's better this way. Yeah. So this was very good. Thanks. Thanks a lot. So we could check the data type by calling the D type. Yeah, I think we'll talk about all this. So we could also change the shape. We could use the reshape to change the shape. To, let's say, then we put the shape we want. We could do that as well. Yeah, but then if it's we could also change the elements, but this doesn't work with a tuple, because a tuple is similar to the list. The only difference is instead of having a square bracket, it has this. It has this bracket. So the main difference between it and a list is a tuple is immutable. You can't change the elements. That's why when we wanted to change the first element here to 2, it gives us an error. So tuple object doesn't support item assignment. Yeah. So we could do some other calculations. We could find the square root. We could also square x. We could, yeah, we could. This is also find the square root. So basically, working with NumPy, it's much more convenient, since given the fact that Python is a general purpose language. So to do certain statistical analysis and stuff like that, working with a NumPy object is much more convenient than in base Python object. One thing also we'll want to do is to generate random numbers, like do some kind of simulation. So we could call the np random.normal, which gives us a standard normal, generate standard normal numbers. So an example could be to generate 50 independent random variables, which are a standard normal with mean of 0 and a variance of 1. So we could do this, and you notice that the thing with this, anytime we run this, we have a different simulation altogether. So this is one simulation. If you run it again, we have a different simulation. So to avoid having different simulations all over, of course, we could also do some other calculations. With this, we could look for the correlation coefficient. We could calculate the mean and all that. But one important thing is, especially if we are doing some simulation, we want to be able to replicate our results the next time we check it again. So for that, we have to set seed. We have to call this random number generation, which is random dot default random number generation. So here we could put in any value. They put this, we could put like 200, we could put anything. But the thing is, this will help us so that this random numbers we generate, we can replicate them the next time. It doesn't just keep on generating different numbers, you know. So that's the use of setting a seed before, just like we have in R as well, before you start doing some simulations. So once we have that, we could call these methods, the NumPy mean, the NumPy variance, the NumPy standard deviation. We could call all these methods to do some more analysis. Yeah, if someone wants to add something, like, or any question, you know, feel free. Yeah, so he looks at graphic. Next, he looks at graphics. So the main package for graphics in Python is Matplotlib. So he mentions something about subplots, where we want to have some subplots of the main plot. So we could import that from Matplotlib. We could import subplots, and we could have a figure like this. But when we use the plot, even though we want a scatter plot, okay. Oh, okay. So she has to leave. No worries. Yeah. So once we call the plot method, although we wanted a scatter plot, but the plot method sort of tried to connect all the dots, which is not useful. So we could. So he's just trying to tell us the various outputs that this subplot method has. Yeah. So when we call plot and then we assign the type to, let's say, an O, then it gives the dots. It doesn't connect all the dots. It gives us a scatter plot, or we could call this scatter plot method. We could call this scatter method, and then this we could use different. We could, let's say, use a plus, and yeah, we could use a plot and a plus, and instead of a scatter plot, it's gonna, instead of a dot, it's gonna indicate like plus for each of the dots, or we could use a different symbol. So basically, we could do a lot of plot with using this, and also, since like the Matplotlib, like all the key outputs, or like the X label, the Y label, these are all objects. So we could do a lot of adjustments to them, because they're like objects. They are not like some fixed object, but they are like some yeah, like there are some like NumPy objects that, you know, you could manipulate or something like this. So we could set the X title, the Y title, the X label, Y label, and we could also set the title and all that. We could also adjust the figure size by using the set figure size inches method. We could use that to adjust the figure size. Then if you want to get the various subplots, we have to adjust. Like here, we want 2 rows and 3 columns, and the figure size is as follows. So this is all quite handy, and depending on the type of analysis you are doing, having a subplot might be very useful. Yeah. So we could also use the dot line space, like the linspace method, to create a different type of plot, which is more like similar to a contour plot, which so this method returns a vector of n numbers, which n is the number of times we want to do this, and A will be the first, the starting point, and B will be the ending point. So an example could be like this. Yeah, we could also use the contour method to create plots like this. Yeah, then it talks about sequencing and slicing in Python. So like we know in Python, we start counting from 0. And I think this is also the case with some other programming languages. So what this does, this like we have sequencing from the first element to 10 with with the total number of total number of sequence or counts to be 11. So which means we take from 0 to 10, which will give us 11 different sequence or count. We could also use the range function and give it a starting point and an end point. If we want, we could add a step. Let's say this step could be a 2 or anything if we want. And then we could also see that. Yeah, we could give it a step and yeah. So like he's stressing the point that Python starts from 0, and that the last element, like 10, is not included in the sequence. So the sequence will stop at like 9 in this case. So we could take intervals. So we want to get from the let's say from the third element to the fifth element of this hello world. We could do this slicing. So basically this is like slicing. So if we want, we could slice also from, let's say we do something like this. Then it will be from the beginning, from the beginning to the fifth element. Yeah, so if we just remove everything, it gives us back the entire hello world. So these are all some slicing stuff that we could play with depending on what we want. So it also talks about indexing. Let's say we have this NumPy object. So this represents the second row, like the second row, the third column. The second row, third column is going to be 6, of course. Yeah, so we can do that, and then it gives us 6. So when we say, okay, now we want the, let's say the second row, second element, no, the third row, sorry, we ask for the third row, second element, we get maybe a 10. No. Okay, maybe I'm missing something out here. I don't know. Or maybe I didn't call this. Oh, okay. Okay. Oh, yeah, yeah. So the problem was I didn't run this. So I think now all here is talking about how to index and all that. So we could just keep this. Just towards the end, there is a practical data analysis example using real data. So we could skip all this and move on to that. So Boolean, like true or false, we could also work with Boolean objects. Like here we have like the object A that we created previously. We try to take the first, let's say the first row, and assign everything to a 0, because np.zeros just assigns everything to a 0, and the data type we assign it's Boolean. So this returns everything is going to be false, because these were not zeros before. Yeah. So we could set them to true, something like that. We could set the second the second column and the third and the fourth, yeah, the second column and the the second column and the third column to true, like to set them to true from here. Once we do that, we have like, now we have false, true, which is the same as this, because NumPy just see this as 0, 1, this Boolean objects as 0, 1, 0 for false and 1 for true, or something like that. Yeah, so now we look at how to like load data frames and do some analysis with an actual data set. So just like in R, we have to import, and he mentions that if we are like just in R, if we are our working directory is different from where the data set is. So to do that, we will have to call this os dot change directory method to change the working directory. So to do that, we have to import the OS and all that. But in my case, the data set is already here. It's this auto data set. So I don't need to change the working directory because it's already in the working directory. So we could use the read CSV because this is a CSV file, comma separated file. So if it were like an Excel or text, then we use maybe the read Excel, the read text. I would say this is just equal. This is just the same as tidyverse stuff. So yeah, so then it gives us the first 10 rows. So we could see this is one of the columns, the MPG, the number of cylinders, the display, the horsepower, and that's the name of the type, like the mark of the vehicle and all that. So we could also remove the white space in the data, something like that, using setting the limit white space to true. So if you want to see any of, okay. Yeah, so we have to, I don't know what you mean. We have to be very careful with the index, maybe. If you could shed light on that.
Oh, there was an exercise in the well, after the lab, in the exercises where like if you don't select any column as your index, then you'll get the numbers like on the left, the 0, 1, 2, like as those will be the names for your row. But you can also select one column to be your index.
Yeah, your
like
index,
in that,
yeah.
So that's kind of we have to be careful with that.
Yeah, thanks. Yeah, like here there is no index. So it's just taking the number of 0, 1, no index. Yeah, so we could set the index to any of these columns. But here he set the index to name, which makes sense. So if you want to have a bias, like a deeper view in, just want to see one of the columns, we could just call the auto and then put a bracket here. But if you just, let's say, call only auto without only the horse power, it will complain because it's like, I don't know what is horsepower. So we have to call the auto and then horsepower. So we can look at the unique entries in horsepower. This was a problem because this was some kind of a missing value. It was a missing value. So we could adjust it and say all this type, which indicates a missing value, let's call them inis. They are like all inis. And we could see the sum of the horsepower, sorry. The shape, we could also see that. So we could see the columns we have. These are the columns we have. So it's like the interesting thing here is, just like we work with columns, we could also work the same with rows. So we could also slice to rows. Like here, when we call the auto and the .3 or let's say .5, anything, it will give us those rows. Here it gives us the first 3 rows. We could instead of 3, we could say 10, and it will give us the first 10 rows and stuff like that. We could also do some other data analysis. We could say auto, look at the column here. We want to get all the cars that are manufactured after, let's say, 1980, after 1980. So, but this will not include 1980. So it's going to be from 1981 onwards, like 81, 82. We could do that, and then we see the year, all the cars that were created from 1981 onwards. We see all of that. So this is all tidyverse stuff. So if we want to look at only just two columns, we could just do this, and we see the MPG and the horsepower. So when we auto.index, we see the index, which is just like you mentioned. So it's 0, 1, 2, blah blah blah. It's the index. So we could change this. We could use the set index method, and now we use name. We could use cylinder. We could use MPG instead of name. Yeah, and now the index, instead of it being 0, 1, it's the name, which makes more sense given the data we are working with. It makes sense to use the name as the index. So now we'll see that name is no more a column, but an index. So we could also work with the log, which allows us to access specific rows or columns by their label, like by their labels. We selected this rows to be equals to this and that. So when we call the log rows, it gives us the position of these 2 rows that we have selected. We could also use the ilog, which gives us their integer location. Basically, they are all the same, but the log font method is more widely used. We only use the ilog when we are just interested in the integer location or something like that. Yeah, so you see, still talking about how to do some manipulations with using the log and the ilog that we have mentioned. Let's say, suppose we want to create a data frame consisting of the weight and the origin of the subset of cars which are greater than 1980. So we could create. So this will be a Boolean object. So it is going to be true if the year for a particular name, like a particular car name, which is the index, is greater than 81. It's greater than 80, sorry, like 81, 82. And it's going to be false when it is 80 and below. So it's this is a Boolean object. So, but now the auto re gives us only the cases where it is true, and then it just focuses on these two variables, the weight and the origin. So we could do this easier by using the lambda function. So when we use the lambda function, which takes in as an input a data frame, and since we call it in the using the lock with respect to the auto data frame, so it gives us back the results with respect to the auto data frame that the manipulation is done in. So it's much more straightforward to use the lambda function. Yeah, so it also talks about using for loops, which are like saves us time, before doing some tedious work, we could just use a for loop. Yeah, you also have while loops, but for loops are more used. So here, if we just want to sum these numbers, we could technically write a program that adds them one by one, or we could even use the sum method, but we could also use the for loop, which adds it. So here it's just like increments. So value increments by total. Yeah, value increments by by total. So we could have nested for loops, like much more complicated for loops. We could have, we could have much more complicated for loops. Like and formatting strings. You also mentioned something like that, how to format strings. So suppose we have generated a random number, random standard normal, have choice, and so sort of creating a data frame, and that's the data frame. We have some missing values. So we could do some string formatting and get the column for any of these columns in the data frame, the D data frame. And we get the number of the percentage of missing values there. But in formatting the percentage, we are like two digits after the decimal place. Yeah, so that is what this signifies, like 2 digits after the decimal place. Yeah. Yeah, I think it talks more about some graphic, and towards the end, there are some functions that he introduces. Yeah, so we could use the histogram method. We could also use the box plot method. We could use that. But we try to make sure that the data is a pandas series, which is this pandas series is mostly used when you are working with time series data. So once we could use the box plot method. We could also use the histogram method. These are all very good descriptive statistics functions. Useful before we start doing any analysis. We could use this to have a much more understanding of our data. We could also do some adjustments with the histogram. We could set the color. We could change the default color. We could change the bin sizes and all that. We could also get some metrics-wise scatter plots. Yeah. Yeah, I think the describe function very useful. Give us an overview of the data. we could call it for the entire data set, or we could just call it for some of like here, we just want to have a summary statistics for the MPG and the weight variables, or we could have the describe for the entire data set, or just here, just for the cylinder, we could have the describe for so it gives us the count, the mean, you know, the like the basic summary statistics measures. It gives us that. Yeah, I think this is basically what the lab covers. If someone has 1 or 2 points that they want to share with us, maybe. Yeah, I'm sorry, I cannot have time to go to some of the applied exercises. Maybe if someone has some reflections on those exercises and he wants to share, I think we have like 3 minutes.
I didn't go through the like the exercises that were more like conceptual, but those look, I mean, they look good too, because they were asking about the bias and bias and variance trade-off.
Last week we did something like that towards the end.
Okay. Oh, okay. Yeah.
Yeah, maybe if you have time towards the end, I think we look at section 1 and 2.
Okay.
Yeah, the exercises.
Oh, okay. I'll check
the theoretical. Yeah, like last week towards the end, I think like the last 5 minutes or something like that, we looked at that.
Okay.
Yeah. So I don't know who should present next. Check.
Yeah, it's me.
So it's Hamza, right?
Yeah. Excited
Okay.
to see you next week.
Yeah, so that's going to be linear regressions. Wow, nice.
Yeah, it's the first very basic algorithm.
Yeah, so we look forward to that.
Yeah, sure.
Yeah.
Thanks a lot for today's presentation.
Yeah, thanks everyone for the patience. It was somehow boring, I guess, but thanks everyone. No, I didn't end the chat. Let me end it.